my name is Amit Patel, a senior design engineer in the Power Products Group here at Linear Technology. Today we're discussing the LT3042, our state-of-the-art ultra-low noise and ultra-high PSRR linear regulator for powering noise-sensitive applications. When it comes to powering sensitive analog and RF applications, low dropout linear regulators are generally preferred over their switching counterparts. However, these applications have reached capabilities and sensitivities that are testing the limits of conventional low-noise LDOs. With its combination of ultra-low noise and ultra-high PSRR, the LT3042 can directly power some of the most noise-sensitive applications while post-regulating the output of a switching converter, thereby eliminating the many stages of LC filtering required with conventional LDOs. In addition to high performance, the LT3042 offers programmable current limit, programmable power good threshold, and fast startup capability. Here's the LT3042's noise performance. It offers 0.8 microvolt RMS integrated noise over 10 Hz to 100 kHz and a spot noise of only 2 nanovolt per root Hz at 10 kHz. Increasing the set pin capacitance decreases the low frequency 1/f noise. With a 22 microfarad capacitor, the output noise is under 20 nanovolt per root Hz at 10 Hz. Note that capacitors can also produce 1/f noise, particularly electrolytic capacitors. As one of its many architectural advantages, the LT3042's set pin can be actively driven by a lower noise voltage reference to further reduce noise below 10 Hz. Additionally, multiple LT3042s can be directly paralleled for even lower output noise. The integrated RMS noise also improves with increased set pin capacitance and drops below 1 microvolt RMS with just 2.2 microfarad capacitance. Ultra-high PSRR is another LT3042 advantage, offering incredible low and high frequency PSRR performance. PSRR approaches 120 dB at 120 Hz, 79 dB at 8 MHz, and better than 70 dB all the way out to 3 MHz. As with noise, increased set pin capacitance improves lower frequency PSRR. Unlike traditional LDOs, whose PSRR deteriorates into the tens of dB as you approach dropout, the LT3042 maintains high PSRR at even low input-to-output differentials. It maintains 70 dB PSRR up to 2 MHz with just 1 volt differential and 60 dB PSRR up to 2 MHz with a mere 600 millivolt differential. LT3042's ultra-high PSRR over a wide frequency range is paramount in powering noise-sensitive applications while post-regulating a switching converter. Nonetheless, in order to achieve ultra-high PSRR, care must be taken to minimize electromagnetic coupling from the switching converter to the LDO output. Shielding or good PCB layout techniques must be employed. With the LT3042 located just a short distance from the LT8614 buck converter and its output inductor and capacitor, almost 80 dB rejection at 500 kHz is achieved without any shielding. To achieve this performance, no additional capacitor is placed at the LT3042 input. Placing even a small 4.7 microfarad capacitor directly at the LT3042 input results in over 10x degradation in output ripple. This is rather unusual, as adding input capacitance typically reduces the output ripple. But at 80 dB rejection, the magnetic coupling resulting from the moderately high frequency switching currents flowing through this 4.7 microfarad capacitor significantly degrades the output ripple. For best performance, we recommend not placing any capacitor at the LT3042 input if located 1 to 3 inches from the switcher's output capacitor. We'll now see a demo comparing the output noise of the LT3042 to that of the LT1763, one of our popular low-noise LDOs. The output of the LDO is gained up from 10 Hz to 100 kHz using a very low-noise 80 dB amplifier, which is shielded inside a mu-metal box inside this cookie box. The output of the amplifier is connected to an oscilloscope and a speaker to visually and audibly compare the output noise. This is the LT1763's output noise on the oscilloscope with an input-deferred scale of 50 microvolt per division. With 80 dB amplification, its output noise is heard clearly on the speaker. Now let's switch to the LT3042. Its output noise is barely discernible on the speaker and just a flat line on the oscilloscope, a significant improvement in performance. In conclusion, The LT3042's ultra-low noise performance opens up applications that were previously not possible or required expensive and bulky filtering components. With its ultra-high PSRR over a wide frequency range, the LT3042 allows lower frequency operation of the upstream switcher for improved efficiency and EMI without requiring any increase in filter component size for powering noise-sensitive applications. The LT3042's breakthrough noise and PSRR performance, coupled with its simplicity and robustness, make it ideal for powering noise-sensitive applications. Please visit linear.com for more information. Thank you for watching.